Hello everyone, welcome to the class. Today we will talk about the transport protocol, one kind of protocol in your protocol like a stack. So what's a transport protocol? And today actually we will talk about what's a TCP. Do you remember? You probably heard about it, TCP IP, right? So what's a TCP? And there's another one called UDP. Actually, UDP is also another transport protocol. So what's the TCP? What's the UDP? What's the difference between TCP and UDP? This is the topic for today. So the protocol is very useful because it's defined rules so everyone can follow it to transfer the data, to communicate. So there's a couple different layers of the protocol. One layer is called transport protocol, which is here. In this transport protocol, you can see there's a transport protocol called TCP and transport protocol UDP. So what's the transport protocol? So the transport protocol try to define for this particular connection, what kind of communication we want to have. Do we want a communication like more like a telephone? I talk to you, you talk to me, or I want this transport protocol. I want to this communication more like just from one way to another way, like answering machine, right? Or the mail. I just send you a mail, then I never get the response. So it's defined how you communicate, how to communicate in different machine, different like machine in different area. Okay. So the first one, let's talk about a connectionless communication. So what's a connectionless communication? You can imagine that you have a machine, you have a server here, and you have a machine in your house, and you try to connect this to the server, but the only thing you care is does the server send data to you? So you only care like how many data sent to you. You don't care what's the data. So you want to get the one direction information. You don't after you make this connection, you just want to get the one direction connection. Just like I want to receive a lot of data. I don't want to communicate to this machine. So in this case, the client make a request, an endpoint on server, and the server just try to respond to it. Okay, so it try to respond to it, and the server doesn't care what's the IP address of the client. The server doesn't like really care like a much deals. It just try to send a lot of information back to the machine. That's it. So what happened in this case? For this kind of connection, we call it connectionless communication. Why? Because it's not like the regular like a communications. It's not like a one-on-one like meeting or conversation, right? So you just like keep like receiving the data. You never like check is the data missed or not. For example, your server try to send you a data, and after you receive something, you don't care like this data is correct or not. You don't want to double check. I received the grade, the grade for my project, and I don't care it's correct or not. I just receive it. Okay, I see this grade is 50. Okay, I will take it 50. Another way, you probably can like communicate with your server. For example, you can tell your server, okay, does my grade is 50 in your on your side, or it's maybe another number. So this is the communication. You don't care. You don't care the data you receive is correct or not. You just keep receiving. So why we need this communication? Sometimes we don't care the quality of the data. We don't care the order of the data. For example, you receive like a ABC, then you receive DEF. You don't care the order. If you receive DEF, then receive ABC, it's fine. It's also fine. So in what case we want to use this connection? Think about the videos. If you have a videos, you try to like for example YouTube, you try to receive the videos, and each connection gives your data, one pixel in this one. So do you care if I got the one pixel is incorrect here? Do you care? If I got like a lot of pixel in your machine, try to like have a videos. Do you care there's one pixel is wrong, or second pixel is wrong. No, you don't care. Do you care you receive this pixel before this pixel? You don't care, because they should be parallel, right? So they should be parallel in your screen. So in this case, you can use this connection because you don't care the correctness of each piece of the data. You don't care the order you receive the data. In this case, you can use this connectionless communication. And what's the benefit to choosing this communication? Speed. So the speed is the benefit. Why we choose this connection? Because we want it faster. If you want to watch a video, do you really care like how many pixels there? No, you don't care. You care how faster I can receive the video. I can watch a video. I don't want to, it's like frozen, like for each seconds, right? So if you use another way, like other different way, for example, you want to double check the correctness, you want to double check the order, then you lose the speed, you lose the time. So we choose this connection because we don't care the correctness. We want it to go really, really fast. We pursue the speed, we pursue the performance, then the quality. So this is the reason we choose this connection. Contrast to this one, there's another connection called connection-oriented communication. For this one, you can imagine that it's more like you have a server and machine. This one send the data to the server, and the server, okay, server receive the data. It will send back to response the client. The machine said, okay, I received this data. Is this correct? Then do some double check. If this is not correct, your machine will say it again until it's correct. Then move to the next one. The next one, your server might give you some information, and your client will try to respond to it to check its correctness. If this is not correct, the server will say again. Then it's responsible again. So this is the connection based on this connection-oriented communication. So it's much safe. It can guarantee the order, but it lose speed. Okay, so there's two ways to make this communication. One is connectionless communication. One is connection-oriented communication. And usually we say TCP/IP. What's the TCP here? Is connection-oriented protocol. So this connection-oriented communication protocol, we call it TCP. And what's this? We call it UDP. So let's say two different protocols. You can follow either one, depends on the purpose, and they give you a different way to communicate between two machines. The UDP don't care the data. It's unsafe. Don't care the order of the data, but it's really, really fast. It's faster than TCP. For TCP, it's much safer than the data is in order, but it's lose some speed. So in summary, what's a TCP? What's a good part for TCP? What's a good part for UDP? For UDP, faster. For TCP, safe. And also data in order. So the safe here means no losing, no missing data. Why? Because if you got any missing data, you will double check with another machine. Then another machine find out, okay, this data is missing. I resend it to you. So it's much safer because there's no missing data. And the data is in order. So you don't need to worry about the order of it. But the downside of this is, okay, because you need to do a lot of check. So it's a little bit slow compared to another one. So in other words, for the UDP, what's the downside? Unsafe. Okay, so this is a comparison between TCP and UDP, and this is a very important concept. Why you choose TCP? Why you choose UDP? You need to consider these feature, these reasons to help you to make a decision. Okay. So this is for today. Today we talk about transport protocol. There's two different transport protocol what we were talking about today. The first one is TCP, which follows the connection-oriented communication. So for this case, the most common case is a client-server model. So what's a client-server model? Client-server model is just like when you like usually like Google it or use any website, your machine is a client. You try to connect to a server, for example, Google server. You request something, and the server passes some information to you. And based on this connection, you need to guarantee the correctness of the data. You don't want to receive the information, wrong information from another your server, right? So we use TCP because TCP guarantee the correctness of this information passage. It will double check the data and like make sure the data is correct. And also it's guaranteed the data is in the same order. So you can like you don't need to worry about the data is messed up when they pass to your client or like your machines. So this is TCP is much safer and it's also guaranteed the data in when transfer the data is in order. But because you need to double check it, so it will be a little bit slower. Another communication is really, really fast because it doesn't care these like correctness, these orders is called UDP. UDP follows the connection-less communication in your transport protocol. So it's use a different strategy. For example, if you want to watch the videos on YouTube, you don't care each pixels the color, right? If the color is wrong, it's fine. If the color is missing, it's fine. You care is the speed. You want to like watch your videos without any frozen. You don't care like what's the order, which pixel come to your screen first. You don't care these details, right? So for this kind of connection, you can choose use UDP because it's used give you a high speed like a communication. Even though it cannot guarantee the correctness, it cannot guarantee the order, but sometimes you want to use this kind of communication. So today we talk about TCP and UDP. So you need to like keep in mind the comparison between the TCP and UDP is very important in this topic. And when we choose TCP, when we choose UDP, and in what situation you should choose either one. So you need to think about it. So, okay, so this is for today's video, and I hope you enjoy it. See you next time. Transport protocol is awesome.